Oh, well, hello and welcome. Beginning from today, I'm going to start a new series in my YouTube channel, and this series will be called Problem on Demand. So, if you are also like me, uh, a student of mathematics, and if you're in passionately love with the subject, and if you're going to recommend me a problem which I find it interesting, I'll definitely take it up. So, it's almost impossible for me to not to take an interesting problem if you're going to throw it at me. So that's problem in demand. So the first problem which I'm going to take up is by Akshat Srivastav, and he's just going to represent India in the International Astronomy and Astrophysics Olympiad. All right, so the problem says that find the positive integers mn which satisfy this equation, and the equation is something like this, right? So the first thing which I'll ask you to consider is that what they've asked us is that what are the positive integers which satisfy these equations? Um, well, if you look at it, if m is positive and n is positive, so it makes this quantity as even, so which means that this quantity is odd, which means this quantity is odd. Uh, so what can we do? Various things which runs across my mind. But what I'm going to do is that what I see is that this number is nice. One is one square and n is n square. So maybe they can be clubbed and they can be factorized. So right. So what I'm going to do is that say that 3 times 2 to the power m is equal to n squared minus 1. And 3 times 2 to the power m is now equal to n minus 1 into n plus 1. Uh, well, now if you have a look at it, then since m is positive integer, so since m is a positive integer, so the left-hand side of this equation is going to be even. And it's not difficult to see that n plus 1 and n minus 1 have the same parity. Uh, Either both of them are even or both of them are odd simultaneously. Right, so since both of them have the same parity, and this number is even, so it tells you that both these numbers must be even, right? So n plus 1 must be even and n minus 1 must be even. So right, so which tells us that these numbers n plus 1 and n minus 1 can be only of the following two forms. One, either n plus 1 can be of the form of, say, like something like 2 to the power a, and in that case, n minus 1 will be of the form of 2 to the power 3 times 2 to the power b, so that their product is going to be equal to this number, right? So how do you think of this? Well, since this is even, so all of them must contain 2 to the power something. But left-hand side also contains a 3, so one of these two factors must also contain a 3. So in the first case, I have assumed that that factor of 3 will be attributed to n minus 1. In the second case, I'll consider that, well, that factor will be attributed to n plus 1, right? So what do you get? What I get is that since uh, n minus 1 is even, it tells you that b is greater than 1 or equal to 1 at least. And since this is greater than or equal to 1, which means that this is at least 6, that tells you that n is at least 7. That tells you that this number is at least 8, right? So it tells you that a is greater than or equal to 3, right? So that makes sense. Now, what I'm going to do is that I'm going to subtract these two equations because n is not a nice thing to have. So let's subtract them. What do you get? What you get is 2 to the power a minus 3 times 2 to the b, and that's equal to 2. Now, since we are utterly convinced that b is positive and a is positive, so let's divide by 2. So if you were to divide by 2, you'll get 2 to the power a minus 1 minus 3 to the power 2 to the b minus 1, and that's equal to 1. Right. Now, the argument here is that, come to think about it, since a is greater than or equal to 3, so which means that this number is still a positive integer, which means that this is still even. And if this number is positive, so this will also become even, and even minus even can't be 1 because 1 is odd. So that tells you that this number must be odd. And for this number to be odd, b must be 1. Right? So b must be 1. And well, if b is 1, then you can sort of figure out yourself that if you were to put b as 1, so you'll get n as 6 plus 1, which is 7. Right? And if you were to put n as 7, so if you were to put n as 7, so you get this as 3 times 2 to the m is equal to 8 into 6. So 2 to the m is in fact equal to 8 into 2, which is equal to 16, right? So m is equal to, I believe, 4. So one of the solutions that we have arrived at is m is m comma n, and that's 4 comma 7 is the answer. So this is one of the answers in which we had attributed 3 to n minus 1, right? Now we'll take the other case. The other case in which we are simply going to say that n plus 1 is equal to 3 times 2 to the power a, and n minus 1 is equal to something like 2 to the power b. And since both of them are even, both these numbers are even that we had argued, n plus 1 and n minus 1, both of them must be even. So it tells you that both a and b are at least 1. Right. So if we were to simplify this, again, we're just going to subtract these. If you were to subtract this, you'll get 3 times 2 to the a minus 2 to the b, and that's equal to 2. Now, if you were to divide this equation by 2 throughout, so what you get is that 3 times 2 to the a minus 1 minus 2 times b minus 1, and that's equal to 1. Right? Right. So what do you get from here? Now, can we agree that, can we sort of stipulate some conditions on A and B? So for example, can B be 1? So if you were to put B as 1, so if you were to indeed put it B as 1, so you'll get N as precisely 3, right? N as precisely 3 would mean that this number is 4. And this number being 4 would mean that this side is not divisible by 3. So what I'm saying is that, say that if B is indeed 1. So if B is indeed 1, so this is 2. If this is 2, then that makes n as 3. If n is 3, so this quantity becomes 4. And this is not possible because this is a multiple of 3 and this is not a multiple of 3. So that doesn't work, right? So, okay, moving on then. So it essentially tells you that B is not equal to 1. And B is greater than or equal to 1, so it means that B must be greater than or equal to 2. And which brings me to the same logical conclusion again, that if b is greater than or equal to 2, then this number is a positive integer, which means that this is even. And if this is even, then this must be odd for their difference to be odd. And if this is odd, then a has to be 1, right? A has to be 1. So if a were to be 1, so you can check that if a were to be 1, so you'll see that the equation that you get is that, well, this becomes 3 minus 2 to the b minus 1, and that becomes 1, which tells you that 2 to the b minus 1 becomes 2, which is 2 to the 1, which means b minus 1 is 1, which means b is 1, or b is rather 2. So you see that b equal to 2 is a solution, n equal to 1 is a solution. And if you are going to see, then if you were to put b as 2, so you'll get n as 5. And you see that if you were to put n as 5, so this becomes 6. So 3 times 2 to the power 1 is indeed 6. So that's a solution, right? So in fact, we have arrived upon one more solution, and that is that n is equal to a 5. Right. And if you were to put this n equal to 5 in the original solution, in the original equation, and then you'll get 3 times 2 to the power m is equal to 5 square minus 1, which is 24, in fact. And so you get 2 to the m is equal to 8, which is 2 to the 3. So you get m is equal to 3. So we have yet another solution, that m comma n is 3 comma 5. And since we have exhausted all the cases, that n plus 1 and n minus 1 should have been of the form the way they have been. So we get that these are the only two solutions to this Diophantine equation. Right. So if you want to come up with more interesting problem, I'd really encourage you to type in the comment section of my YouTube channel, or if you know me personally, you can send it via an email, or you can send me on WhatsApp or a text message, whatever you prefer. All right, so that's all, and bye.